everybody, welcome back to the channel. This is Charlie here, Rookie Farmer. Behind me I have my Vermeer 403F, and I did a conversion of going from a manual twine tie to a electric twine tie. This conversion is fairly simple, and it would probably work for a multitude of balers, not just a Vermeer. So if you have a manual twine tie baler and you're looking to go to a electric twine tie, it's pretty simple upgrade. A few basic you may need some machine tools or welders, but for the most part you should be able to cobble something up and make this work. So I'll kind of give you a brief overview of what we have and then get started on making this. I already have the system installed, so the video is going to cover how I went about installing it, where I got the electric actuator, and what I did to mount it to the system to make it function, how it's wired, and how I use it in the tractor. So anyways, please like and subscribe, stay tuned, and watch what's going on. All right, here we are. This is some of the stuff that we got. This is the Glide Force. This is the linear actuator that I received, that I ordered for it. See if I can get it up here. You can see the part number and its rating. It's a 12 volt. The tractor's 12 volts. Got 4.02 inch of travel, 21 ratio, and maximum load is 562 pounds. And the reason I chose this one was because of the weight, the maximum load, and the travel speed. It travels 0.61 inches per second. You can find tons of these actuators on eBay. They're super cheap, but their downfall is that they're super slow. The thing for this twine tie, it needs to travel a total of 4 inches, the full 4 inches. So you figure 0.61 per second. That's a little over a half inch, almost 5/8 of an inch per second. So to travel full 4 inches, you're looking at 8 to 10 seconds. So be able to go back and forth around that time frame. So that's the reason I chose this speed. So you kind of see what it looks like. When I purchased it at the surplus center, price was about 290 bucks plus tax and shipping. So that's the website. It's surpluscenter.com. And this is what it looks like. I'll take it out of the box. You'll get to see it later. Alright, and then you're going to need a few other things. So Harbor Freight and Home Depot is your friend. I got this electrical box. It's sealed, plastic, with external mounting tabs. It's a 4x4 box, electrical box. eBay or Amazon. I'll post links down in the description for these items that I got. These are my my Momentary double pole, double throw switch, and I believe this is rated like 16 amps. So, and I think that's the max load that this is, 16 amps. I'll cover that later on. But it came for 2 for the price of 1, I guess. So I'll post a link, like I said, down below, and on which switch that I got. I bought this heavy duty electrical cable. Got it at Harbor Freight. I went with 12 gauge, so I would suggest you do the same thing. I got a 25 foot. I'm going to be cutting the ends off of it, and this will be the cable going up to this box for the switch for left and right of the actuator to move. I'll show you how it's going to get wired. It'll be a diagram. I'll post that in this video. But anyways, cheap electrical cord. And there's some other things. I'll cover those. I got to dig them out. They're liquid type fittings, so they're kind of like an electric box that you clamp the wire down onto. I don't know what they're called. I'm not an electrician. So but I'll show you the fittings that I got. I bought them from a previous project. In my videos you can see making a wipe for your cattle. So I still have some of those extra fittings, and I believe it'll work great for this size of the wire. So I'll be using those to tie it into the box. I did buy a magnet at Harbor Freight while I was there, because I was unsure if I'd have a place to put it or how I was going to mount this in the tractor. Being the inside of my tractor is covered in plastic on the interior, there is a spot to mount your controller for your hay baler in there, but I don't have that bracket, so I may just put a piece of steel on there and then attach this magnet to the back so I can just stick it on there, and whenever I'm done with the baler I can wind this up, pass it back through the window and get it out of the way, or unplug it. However, I may put some connectors on the ends of the wires, I'm not sure. We'll cover that later on in the video. But anyways, you're gonna need some miscellaneous hardware, etc. This is gonna be a fabrication job, so you know, access to some good hand tools, metalworking tools, grinders, welder, all that kind of stuff may be necessary. So let's get started on it. Okay, we are at the baler, and I went ahead and deliberately took the I'm not sure what this is called, like a hay catch or strainer or whatever. So here we are. I have the linear actuator, and here is the mechanical tie system. The reason why I want electric is because I've got a new cab tractor, and it makes it a little more difficult to run this rope and do that, and it gets tiresome yanking on this thing. So what we're going to do here is this baler had the option for a hydraulic twine tie, but this baler is really old and that option is no longer available. I haven't been able to find one either. So what we're probably going to do is unbolt this whole mechanism and remove it off the baler and determine if I'm going to mount the actuator externally or mount it internally inside here. I'm thinking it's probably, I may go out here, still undetermined yet, and welding on a extension, a pivot, the tie-in point off of this end. Most likely when they had the hydraulic system, you know, you're not going to need this spring for your manual return or pull to this side over here. Most likely they kept this same arm and this point right here for the mounting, so I can get it underneath here. This hydraulic ram probably mounted onto here and again onto here, and drove it how it's supposed to. Where if I try to, these pins are much larger than the holes in here, and I'm not going to drill these out. So that's the reason why I'm thinking that I'm going to make it where it mounts out here, and then weld the distance for here to this pin here, extend it out this way, so that way I have the access to it right here. We'll know when I take this all off and make my determination what I'm going to do with it, and then we'll go from there. Anyways, this is this, and once we get this off, I'll show you what I'm going to do. Alright, so now we have our twine tie mechanism off. Like I said, this is for Vermeer, so you'd have to adapt to your particular tractor and what best suits you. But anyways, we got this off. I'm going to go ahead and start taking some of those assemblies off, mainly this, and then like I said, I'm going to make a determination on how. Most likely I'll just get the spring out of the way and go ahead and knock this spring pin out. So hopefully I can knock the spring pin out, because it's in a position that's not healthy to get out. I may have to drill a hole through the top of that to get it out, or cut it off and then drive it all the way through. We'll see. Anyways, so we're going to get this apart, have this ready to come out, because there's another spring pin that holds the shaft onto here. So we're going to get that out so it's easily moved, get some of this junk cleaned up off of it. Alright, I wanted to cover something on this. I needed, for my ideas that I need to mount this to the rail, this position, the whole position, it was wrong. It's rotated now. But they got a nice little sticker on it that says warranty void if the seal is broken. Well, I took a chance, because there's no way. I tried seeing if I could loosen it. I removed the nut that was on here. So I was like, and you can't spin it. I put some pretty good torque. There's no way that thing's that tight. So anyways, when you take these 6 screws out, let's see if we can take this off, and voila, it's notched in there for this nut, so it can time it, so you can move this wherever you want. So I don't know why they put a seal, you know, a void seal in there if you needed to move this position. So I changed the position and locks back up on there, so we'll get this bolted back on. But I wanted to cover that if you needed to move that there's no spring pressure or anything like that. It's just merely mounted on there. That's it. So other than that, we'll get back in there shortly. All right, we're back at it. So I'm going to try to explain what I'm going to do before I start. I decided I'm going to have to cut this off. There's no other choice. So what I'm going to do is mark like a grinder wheel, a cutting wheel or something, put a mark on here that's more permanent, so that way I know where center line of this. So what I've done is I've taken all my measurements prior to ordering this actuator, that I needed 4 inches of travel for this to sweep over to do the twine tie. So, and this pivot point, or from here to here, is what gives me my ratio of being able to push this over, requiring 4 inches of travel. So I have to get my pin back in the exact same spot that I had before with this measurement here. So how it has to work is this will go in place. There'll be a pin that sets back here, and you want your pins to be in the same position, so as it rotates this can tilt, you know, to help with the actual, so it won't bind. So this needs to be able to tilt like this as it moves. So I'll have to set a pin back here. It'll be for here, and then reset the new pin. As I noted, these pins are like 3/4 inch diameter, and that's too big to drill this out. You wouldn't have enough wall thickness left over for this thing. So henceforth I have some 1/2 inch rod, and then I'll build this up so that there'll be enough pin coming through that I can pin this off. Same thing with this, to be able to pin this off so it can function this. So these will have to get cut off. A bracket, the pin will have to be welded here, and then the new pin will have to be welded in place there. So anyways, we'll come back once we get this cut off and get these 2 welded in position. All right, we're back, and I went ahead and machined 1 pin. This I made out of some 7/8 steel. Went ahead and cross drilled it for a cotter pin, and I didn't have any 1/2 inch washers. They were nice and thick, so I went ahead and bored those washers out so we could put that on there. So now I'm trying to do this one-handed here. I'll bring this up here. You can see, I'll slide in like so, put the other washer, and then I've went ahead and marked it on here where this needs to weld into position to align. Here's with my center mark that I marked after I cut that part off of there. So we'll end up machining another pin once I get this one welded and set in position, so I got a good firm fixture of where on welding that onto here. So anyways, when we come back, I'll have this all welded and we'll be setting up to put the pin on this side. All right, we are back, and like I said, I got this pin welded on and I machined an identical pin to go on this end. And here's our alignment mark. I went ahead and extended it all the way to the manual park position, basically, or locked in position. And so now I have this extended all the way out. So now I can just set this in position, weld it in place, and voila. So what we've done is, with this all the way in the stopped position, this rotated and this all the way retracted, we were able to set that pin so we'd have alignment here, and now we run it all the way out just to make sure, and we can weld it right there. So when I come back, we'll have this all welded up and ready to go. All right, we got it all mounted temporarily right now. So what we're going to do is, I got a 12-volt battery here. Step around so you can see. This drive has basically a slip clutch in it, so once it's maxed out, it slips. So let me see if this is the right way. See, there's a stop right there. It's fully extended. Said that was my point right there. So now we switch it around, and then it'll go to the next stop, and voila. So now we can go back the other way. Voila. So that's the mechanical part. So at this point, we're going to go ahead and bolt this thing back into the baler and get these tidied up, and then we'll start the wiring from there. All right, I got the thing all mounted back in. It's just temporary, it's not adjusted yet. I went ahead and ran it to the lock position. I have my extension cord that I purchased for this project, so I ran it in the same manner as the hydraulic hoses that go up to the tensioner, so I can strap them right to that. I'll cut these off a little bit shorter so I don't have too much unprotected wire, and use the sheathing on this, and then heat shrink that all, solder it all together and go right there. I may I'm trying to decide if I want to put a connector in here yet. I'm going to look, see if I have any that's heavy duty enough. If not, I'll just direct solder them, but I'm going to hope that I have connectors. It would be nice to be able to disconnect that if I needed to. So the cable runs through, goes down in here underneath, just like the hydraulic hoses. What I did is there was a hole on the side of the here, and I drilled it out, I had a rubber grommet, added in there, zip ties on both sides to keep it from being able to pull tight or loose, and then I have it run through up into the tractor. So at this point, we're ready to go ahead and get this wired, and then I'll wire up the box and we'll go from there. All right, here we are with the box. I have the actuators all mounted, the wires ran up into the tractor, so it's time to do the box. All right, this is a double pole double throw switch, momentary, so it goes back to center, so it'll be off when it's at center. The switch is rated for 16 amps. It has 1/4 inch push-on connectors, but I'm going to solder mine in place, all my wires. I have, these are like water liquid tight type seals, so actually these work perfect. I got these on Amazon. They're came in a 12-piece pack. You might be able to buy them individually, but it's for 1/2 inch MPT. That means this end down here is 1/2 inch MPT, but it has a nut on here with a seal, so you can seal the back side of it on there. And so what'll happen is the cable goes through here, the insulation goes through it, and then you tighten this nut down and it crimps down on it, and the seal seals off that. Not necessary. This is going to be, doesn't need to be watertight being in the tractor, but I'm going to put it on there because I'm going to cut this down. This is the leftover cable after I ran it in there, and I'm going to make 2 entries into the box. One's going to be for my power in, so whatever in your tractor that you got 12-volt supply is come in here, and then it'll go out to the tractor, and I'll put a switch, or not a switch, but another connector off this box, so I can plug in to that and leave this monitor basically inside the tractor all the time. And I'm going to end up using the magnet that I purchased. Got this at Harbor Freight. So I'm going to bolt this to the back side of this box. It's good and strong. It'll hold this box to the frame inside the tractor, because there is a spot I can put it. So I'm going to mount this switch up high, because later on I may want to add a bale level indicator on here. So I'll put a buzzer on here, and then maybe a LED light, but that'll be for a later upgrade. But right now all I'm worried about is being able to electrically drive that actuator. So the actuator itself is rated for a max load of 13 amps. So that henceforth the reason why I have a 16 amp switch. Like I said, momentary, double pole, double throw. And when you get this actuator, it does have a wiring diagram on there. I was going to explain it, but I've been using these kind of diagrams for many years, or this type of switch wiring, using these double pole, double throws. So what this does is that you'll have your battery coming in to the common parts on the switch, and then whenever you flip it to one side, you'll have your red and black, or your positive and negative, to this actuator over here. And when you flip the switch, it'll reverse the polarity and send it to that. And then if you switch it to the other side, it'll be the normal polarity. So that's how you get the forward and reverse, or in and out, on your actuators, simply by using this switch diagram that they have on here. I will get a fuse, and I'll put in line on this thing. Whenever I get this all wired up, we'll have this fuse. I'm making a temporary connector. My tractor has a amp 3-prong connector. I'm guessing that's for a monitor. I found those on Amazon. I didn't realize I had it, so I'm going to make a temporary connector in the tractor for this to work until my amp connector gets in place. But I'll have the links down in the description for all the items, these switches. These, like I said, I got them on Amazon. And then, like I said, the electrical cord, I got that at Harbor Freight. It's a cheap, and it's a 12 gauge. So you wanted something heavy so it can carry potentially up to 13 amps. And DC over a distance, so you don't have a voltage drop. So you want the heavier gauge wire that you can. Anyway, so we're going to get this switch mounted in here. So I'm going to use a Dremel and a little burr bit to cut this open, slide that in place, drill my holes to put these 2 connectors in here, and get it all wired up. All right, here we are. We have this all soldered up. I have a longer cord for my power in, and the shorter cord I'm going to terminate it and put a connector at this end, so I don't have to take this monitor out and put it in the baler. I can just unplug it and leave the cable inside the baler. So it's wired per the diagram. So we have 2 leads that are jumpered, crisscross jumpered. So from this pin goes over here to the opposite diagonal pin, and then this pin goes from here diagonal over to this pin here. The power coming in is the longer cable that goes into the 2 center pins, and those are by themselves. And then the jumpered, the pins, or the leads that goes out to the motor, are jumpered with those cross pins right here. So basically what happens is power coming in, if you push the switch to this direction, it would go and crisscross the power over to these pins, because it would be open on that side. So it crosses it over and gives positive and negative on the opposite leads. If you go the direction it's intended, it's going to send positive and negative directly over. So this is what gives you your forward and reverse, or in and out, whatever you want to call it. So we have that done. I have my box drilled with my liquid tight connectors. So I'm going to pull these cables through and go ahead and seal this box. Or actually, I need to drill and put my magnet in on the back side of it. And we'll get that done and get this box sealed up, and we'll be ready to go. All right, we're inside my tractor. We have this thing temporarily wired because, like I said, I don't have my plug. I didn't even actually realize that this plug was here because I just got this tractor. And so I'm going to order the connector that goes to this. It's a amp 3 conductor for a tractor. I'm guessing it's for, you know, monitors, other implements. It may require 12 volt because there's a ground. There is an ignition 12 volt, and then there's a constant 12 volt. Right now I'm on the constant 12 volt with the ground temporarily wired on my connector. And then here's the box. Have it mounted via magnet, and it came out great because the left, or this side here, represents the thing in the park position, and pushing the other way will sweep it down to wrap. So I'll show you what, right now it's in the park position. Maybe you can see it through the window here, but we'll go ahead and you see we got to drive, and then we can come back and it parks. And that's it. It's done. So it worked out great. And I had some felt that I put on the back side of this magnet so it wouldn't scratch up everything. So I used some spray contact cement to put that on the back, screwed it down on there, and it's good solid lip. I can put it on either side, but it works great for me because I like looking over the left side because most of the time when you're doing tractor work, you're always looking over your right side sometimes, and it helps to balance out the neck strain. So anyways, this is my electric time tie that I've made on my old manual baler, twine tie baler. And so at this point, really not much else to cover. Please like and subscribe. If you have any questions, please drop them down in the comments section. I'll do my best to give you a hand. Other than that, thanks for watching, and we'll see you on the next vid.